all, it's basic physics and chemistry. It's physics and chemistry that we have known since the 19th century. Carbon dioxide is a greenhouse gas. That means that it's relatively transparent to visible light, but relatively opaque to infrared. Or make it even simpler, light comes in, heat gets trapped. So if you put more carbon dioxide into the atmosphere, more heat gets trapped. And sooner or later, the Earth has to warm up. That's basic physics, and there isn't really any other possibility.
I think what a lot of people don't realise is that the history of climate change is a very long one. History of climate science. It was started with Joseph Fourier back in the 1820s.
Despite what you might have heard, this is not new and controversial science. We've known about the greenhouse effect for nearly 2 centuries. Joseph Fourier, a scientist who's well known for the mathematical technique known as the Fourier series. He is the same scientist who produced the law of heat conduction. He's the guy behind the law that governs how heat moves through substances. He understood that there was a greenhouse effect.
It's all just basic science. It's physics and chemistry. And the key thing to know is that this isn't some new thing that Al Gore cooked up a few years ago. It's rooted in the basics of physics and chemistry. The experiments on this started 200 years ago. So yeah, you might see some headline that questions some aspect of it in the news, tomorrow. But that can't affect the core, because the core is so grounded in what we know at this point that you'd have to tear up most physics and chemistry textbooks for us to be wrong.
So the next person in the story is John Tyndall, who's an Irishman who did some very careful experiments in London in the 1860s on the absorption of infrared radiation by various gases. He tried lots of different gases. He had normal air and water vapour and carbon dioxide and methane and other hydrocarbons, measuring how much infrared radiation was absorbed by these gases, and he found that various greenhouse gases, as they're now called, so carbon dioxide and methane and so on, they absorb infrared radiation in this laboratory experiment, and so this is the basis for what we now call the greenhouse effect.
Climate science is 150 years old. We know that CO2 is a greenhouse gas. And if that were false, then airplanes would fall out of the sky because the rest of physics would be false.
In the late 1890s, we have a Swedish professor, Svante Arrhenius, who was the next person to start investigating this problem. And he was mainly concerned with explaining ice ages, what could cause these large temperature changes in Earth's history. But also at this time, it was becoming realised that the emissions of greenhouse gases from human activity could potentially be changing the composition of the Earth's atmosphere, and therefore the role of carbon dioxide could be more than just explaining Earth's history. It could be potentially changing how things change in the future, and this is becoming more important in the late 1890s. So Svante Arrhenius, he went away and again sort of did some very simple, relatively simple calculations on what would happen if the amount of carbon dioxide in the atmosphere was doubled. The kind of thought experiment, if you like, and he came up with a number of around about 4 degrees or so for the change in global temperature if you doubled carbon dioxide in the atmosphere. And this is the first estimate, if you like, of what we now call climate sensitivity.
And the physics behind that causing warming are the same physics that the Air Force used to put sensors on heat-seeking missiles. And in some really fundamental sense, if you deny the global warming effect of our CO2, you are claiming the Air Force doesn't know what to put on their heat-seeking missiles. It's absurd.
My scientific hero in this story is an amateur meteorologist called Guy Stewart Callender. He was a professional steam engineer, and that was what he did as a day job. But in the evenings and weekends he used to collect temperature measurements from around the world, and he was a very avid meteorologist. He took measurements in his back garden, and he just enjoyed collecting data from temperatures all over the world. And in the 1930s he started to put together a global average temperature. He put together readings from 150 stations all over the world, and average them all together to try and get an estimate of what the globe was doing, instead of just looking at 1 or 2 locations. And what he saw was the Earth was warming up over the previous 50 years.
The first thing about climate warming is that the physical basis, we've known it for centuries. This is nothing new in science of climate change today. You bring more CO2, more greenhouse gases in the atmosphere, it warms it up. It's undisputable.
The rate of emissions was thought to be far too slow to affect global temperatures back in the late 1800s, but by the start of the 20th century, the rate of emissions had gone up an awful lot. And so it had begun to realise that perhaps the rate of human emissions of greenhouse gases could affect the global temperature. And so Callender also collected for the first time the available carbon dioxide measurements, and he showed that carbon dioxide in the atmosphere had gone up because of human activity, and he linked that to the rise in temperatures that he saw. And he did some simple calculations like Arrhenius had done, and showed that carbon dioxide could explain about half of the observed temperature rise that he'd seen in his data.
And if you read the work that scientists were writing, say back in the 1950s and even 40s and 30s when they first started worrying about this, this is what almost all of them said. Almost all of them said, well, we don't know for sure when this will happen, but sooner or later, unless we're missing something, the Earth has got to warm up. And guess what? That sooner or later has passed, right? And here we are.
Over time, the evidence has become more and more overwhelming that we're having a very damaging effect on the climate system, primarily because of our love affair with oil and fossil fuels.
We know that has thermal properties. We know that's going to warm the planet with further fossil fuel emissions. There's absolutely no doubt about that happening.
So the evidence is very clear where we're headed, and the fact that the humans are driving it. It's a matter of physics and chemistry, and at the end of the day, science is about what is, and what is we're changing the climate system.